Hey friends, welcome to the channel, welcome to the homestead. Is there something wrong with your solar system right now and your panels look just fine? Well, today we're gonna go over tracking down problems with your solar panels and your solar system. I'm gonna show you the steps to do that and the tools to use. Let's get going. Our system has been up for about 5 years, with some additional panels out front of this array that were added about 3 years ago. Just recently, I noticed a big drop in the production. So the first steps you want to do when your system is not operating correctly is go through all of the parts and pieces to see if they are operating properly. You can look at the settings in your inverter and also look for any connection issues around the inverter and in your main panel in your house, or wherever your system is connected to your home. If all that's good, then more than likely it's your panels that are the issue. Some of your observations for a problem are that your batteries are charging slower than normal, or your loads aren't running properly and it's overloading your inverter, and that you just can't get the amount of power that you need or expect out of your system. Now, the best place to start is those inverter settings. And if those are set properly, then you want to look at the monitoring app and make sure that each PV string or each solar string for your panels coming into your inverter is producing properly, or to the expected output of what you designed into your system and into each string. If it's not, there's an issue. Now, you do want to check at your inverter to see if you have trouble with one of your MPPTs. Each one of these inputs right here is a string for our PV array. Now, we know that one of these strings is bad, so the way to check to see if it's the MPPT is to switch the strings. Then go to the monitoring app and see if that bad string has changed to a different MPPT. It's pretty easy for this FlexBus 21. There's PV1, PV2, and PV3. And those are labeled underneath each PV connection point and on the monitoring app. So what I did first was switch two of these around and determine that all of the MPPTs are working properly. Now, the next two steps you can interchange. One, you can check each panel's voltage individually. What you want to do is isolate the PV string and disconnect that string from your inverter because it is under load right now. Now we've isolated that one, and if you have a different PV disconnect, also turn that off. What we can do now is check each individual panel. Disconnect the wires and go from the positive to the negative on each panel, checking them. You want to make sure the voltage on each panel is the same relative to each other and also relative to the information sticker on the back of the panel. To test a solar panel for the proper voltage, just insert the negative probe into the negative MC4 connector on the solar panel and the positive into the positive. Make sure you're coming in contact with the metal inside of each MC4 connector. And here we've got 33.6 volts. That's consistent with what it should be on the information plate. Okay, we want to see if there's any connection problems in the system. So at each point of connection, you want to make sure things are tightened down properly, like all the connection points here, and that you are getting consistent voltage through it. So we go to the top of our string right here and we look at the voltage, 219 volts. That is consistent with the string voltage of that front array. We can also come down to the bottom side of the breaker and confirm that the voltage is the same, 219 volts. Then you can come into any combiner piece like these DIN rail terminals here and see if the voltage is the same as 219 volts. So we know that the voltage is getting through the system and back to our inverter. And if you check the voltage in your monitoring app or even back at the MPPT on the inverter and notice that it's the same, then we don't have a voltage problem, we have an amperage problem or a current problem. Now, I showed you in a previous video a thermal camera, and you can point the thermal camera at each individual connector, including these breakers and MC4 connectors, to see if any of them are heating up, which would indicate a loose connection. But remember, increased heat in a connection can cause a fire, so you want to find those. If you're interested in this, it's linked in the description below with a coupon code. Now we can look at another way to diagnose the issue in your system. You've checked voltages with your AC clamp meter, but to check current, you need a DC clamp meter. Fluctuating current in a PV string can mean a few different things. We'll talk about that in a second. I'll have links for both of these in the description below the video. But let's put this on one of our PV conductors and see if there's an issue that way. Now I'm going to come over here to the positive and negative of one of my strings. I'm going to look at the amperage. This one is about 8, and this one is -8. You want to try to do this in full sun so you can get a good reading. You can come over and do that same thing at your combiner box. We're going to look at this string right here. This one's 14. I know it's from my other string, and its partner over here is at 14 or -14. So here we are at our front array, which I suspect is the problem child, and we're going to look at it. So you can see it's certainly an amperage problem. Our amps are jumping all over the place. And you can see that's the case on the negative also. So if you see you have a current problem or amperage problem and not a voltage problem, this is what it could be. So what it means is we either have high resistance somewhere or low resistance on another path. High resistance can be a bad connector where it is just not getting through. Low resistance is probably going to be a short circuit where it's looking for a less resistive path to go through. And that usually is a cut wire touching a frame, a metal frame somewhere. There is fluctuating amperage in that front array, all over the place, all day long. And you can see that from these graphs that I pulled from my monitoring app. You can look at the watts and the volts for each PV string or each MPPT. And for the good strings, you can see these somewhat smooth curves. Now there are little dips because the sun sometimes goes behind a cloud, but it's very temporary. On this bad string, you can see that the wattage is all over the place. That's because the amperage is all over the place. But here, you can see that the voltage is relatively the same. So we need to look for a bad connection, a cut wire that's short-circuiting, or there's a third option, and that is a bypass diode in one of the panels. Those bypass diodes will cause fluctuating current, but the voltage relatively stays the same. And it's usually when you have a damaged or failing diode in the panels that it will do that. And to be able to look for the bad panel or bad diode, we're going to do what I mentioned earlier. We're going to isolate the string by turning it off so it's not under load. We're going to disconnect the MC4 connectors on the panels, and we're going to isolate the panels one at a time. So what this means is on that 7-panel array out there, I'm going to disconnect the last panel and connect the full string to the 6th panel. I'm going to run those 6 panels to see if there's still amperage fluctuation. That would tell me the bypass diode in the last panel is bad. Then keep repeating it down the string until you find the bad panel. And as an aside, bypass diodes can cause hot spots in the panels and at the diodes themselves. So again, a thermal camera is going to be a very valuable tool for you. Okay, I've disconnected this panel right here, and I'm going to reconnect to the panel next to it. Now the voltage on the full string is going to drop, obviously. I took a panel out, but I want to see if the current is still fluctuating. I didn't get that lucky. It's not this end panel. Okay, you've gone through all of that and everything seems to be working fine, but you're still not getting amperage on a string. There is one more thing that could be the issue. And if you want to check this first, you most certainly can. Each MPPT in your inverter has a voltage range. You certainly do not want to go over voltage and damage the inverter. But remember, for each MPPT, there is a low voltage number. That's the voltage that wakes up that particular MPPT. If you are right on that line, it could be switching off. And that can happen in the summertime when your panel production drops. And the voltage drops, which means you are under the threshold for that MPPT. Then it will click off and not draw any amps through it. And if you start off with a string that is at that lower threshold, and over time, some of your panels lose efficiency, then you could go under that voltage. And then that MPPT won't start back up. So the recommendation is, for each string that you put together for each MPPT on the FlexBoss 21, each inverter is going to be different. That you stay 10 to 15% under the max voltage. So for larger inverters like this, you do need a decent amount of panels to run them properly. And if you're right on the edge and you lose a little efficiency over time, they're not going to work. And that's what happened in our case, so make sure you pay close attention to that. So if you're not getting any power to your system from your arrays, those are all the different things that you need to check over. You can check them in whatever step is best for you to start with. I really hope that that provided you with the tools and information that you need to diagnose any issues with your solar system. I'm happy to answer any questions you have in the comment section below. And if you have a different way of doing it, let us know. Have a beautiful, blessed day. We'll see you next time.